Hi, welcome to the channel. In our today's video, we will learn how to make use of a solar panel to make it work without the help of a battery. So for this, I have placed the components that we will be using and testing. So let's start from the solar panel itself. So I'm using the 50 watt solar panel from the product named Loom Solar that I'm then. For testing the output, we have a DC fan, that is a computer cooler fan that is rated for 12 volts 0.15 amps, and then this is the multimeter to check the voltage, and then we have a DC bulb which is rated for 7 watts 12 volts. One thing that we have common here with the fan and light is that these two components, and mostly the DC components for solar, works with a voltage of 12 volts. Okay, so whereas the solar panel output voltage is more than 20 volts. So in order to make these components to work, we need to convert the 20 volts, that is more than 20 volts, to exactly 12 volts. For that purpose, we are using this component called LM2596 DC to DC converter. So this component is a step down voltage regulator or a buck converter. So you have the input here, that's given as input, and then the arrow mark that goes towards the output. So towards the input, we will be connecting the solar panel terminals, that is the positive red and the negative black. So this will go to the output, that is the lights and bulbs and all the components that we are using it in our house. So to generate the exact 12 volts, we have the a tuner over here. So using this, it's also called as a potentiometer, on which we will be able to tune it and to get an exact 12 volts at the output. So we will see that during the testing. Okay, and one thing we need to know here is the specification of our solar panel. So what is the specification? So while you're buying the solar panel, you need to know at what to which watts this solar panel generates the output. So to see that, we need to tilt the solar panel, and let me show you that. Right. So here we have the specification. So let's read one by one that is given on the boxes. So the first one is the power, that has a unit of watts. This is the first rating that you need to note down for every solar panel. So here it's given as 50 watts. And next, the first one is maximum power, 50 watts. Second one is maximum voltage, which is given in V, that is 19.95 volts. And then maximum current, 2.51 amps. Then the open circuit voltage that you need to know, that 23.26. It means that this solar panel will give an output of 23.26 volts when no load is connected, that is no components are connected to the output. So here is the output of our solar panel. So this is where we will be getting the output voltage from our solar panel. So either side, there are two terminals or 2 points. So you need to connect 2 wires from each points. So one is the positive and one is the negative. So let's test what is the output voltage. Okay, now I have the multimeter in my hand. So the other end of this multimeter goes to the positive and negative of the solar panel. So let's see what is the voltage that we get inside the house. So to see the voltage, I need to turn it to V dash dash. So dash means it's DC. So I need to turn it to 200, which is above 23 volts. So 200 volts. So I have kept it to 200 so that it can measure up to 200 volts. So now inside the house, the open circuit voltage from our solar panel is 13.7. So let's see the same voltage when we take this solar panel to the rooftop. So now I'm at the rooftop. So I've bought this 50 watt solar panel and placed it in the sunlight. So let's see the time now. I think the time is visible. It's around 3:10. Okay, and still we have the sunlight. And let's test the voltage now, as I've connected the multimeter to the terminals of the solar panel, to the positive and negative. And here I've connected the positive end to measure the voltage to the, that says V ohm MA, and the black that goes to the ground is connected to the COM. Okay, now let's test the voltage by just turning the dial to 200. Now we can see that this 50 watt solar panel is generating a voltage of 21 volts at 3 p.m. in the evening. Okay, now let's see what is the current now. So to test the current, I need to just change the probe from here to that says V to 10 amps. And also I need to first change this to change the dial to 10 amps, and then I need to insert the plus to 10 amps. So now we can see the voltage is increasing as the sunlight is increasing. So now I'm getting around 1 ampere to the max, and at 12 p.m. I think it will reach to 2 amps. Okay, let me turn it off. Okay, now next what we will do is that we have another solar panel that is placed next to it. So these two solar panels are of same specification, that is 50 watts and monocrystalline. So what I'm going to do is I'm going to connect these two solar panels parallelly. So let me connect it in parallel. So now I have connected both the 50 watt solar panels in parallel. So combining these two solar panels in parallel gives me an added power as an output, that is 100 watts, and a variable voltage depending upon the sunlight to the maximum of 21 volts that I take as an output from this low voltage silk wire that goes to the room. So now we will go to the room and start stepping down the voltage to power the 12 volts appliance. So now we are inside the room. So this is the wire that we got from our solar panel. So this wire extends to about 5 to 6 meters to reach the room from the panel. So let me explain you the connections. So this one, the yellow side is the positive and white side is the negative. So if you have any confusion with the polarities, you can test with a multimeter. So I've already tested it, so I can identify both with the colors. So what I've done is I've connected the positive side to the miniature circuit breaker. So this miniature circuit breaker is used for protecting the circuit from any short circuit. So mine is rated as 10 amps. So when you're implementing this for your project, you can choose 5 amps because 5 amps will be suitable for 100 watt solar panel. Okay, then so the output will be the positive. So this positive is given to the LM2596 module. Right, so and then this negative part is directly given to the negative of the input side of the LM2596 DC to DC voltage regulator. Okay, so let's know something more about this LM2596 voltage regulator. So this regulator is rated for maximum voltage of 40 volts. So it can handle a maximum voltage of 40 volts and a maximum current of 3 amps. So that is why we have chosen 100 watt solar panel, so that the output will be around 3.5 amps combined to both solar panels, that is 50 watts and 50 watts. The combined output current will be 3.5 amps. So also we have to consider that while the current is traveling from the solar panel to the house, there will be some losses in the wire also. Okay, after the losses you will get around some value of current within 3 amps. So let's test that. So let's test what is the voltage and current. So let's start with the current. So I've connected the positive to the current measuring side, that is 10 amps, and the ground side to COM. Okay, let me set it to 10 amps. So the positive is here and negative is to this point. So we can see the current is about 2.88 amps. So you're now ready to give 2.85 amps to this module. That is the LM2596 module. So it will not affect the performance, provided that if the current exceeds 2 amps, you need to provide a heatsink or a cooling circuit. So we will use this computer fan as a cooling fan for this LM2596 module. So I will tell you how to do that, and then also we will measure the voltage also. Let me connect this part to voltage, and I will set this to 200 because our maximum value is above 20 volts. So I will place the plus here and the negative to the same point. So we can see the voltage is 21.2 volts after the losses. Right, so now I'll turn it off. Now it's time to turn on and give the power supply to the voltage regulator module. For that I will just turn on the switch. Okay, so immediately we can see the red light turned on the module. Okay, now to check the output voltage, we need to connect the multimeter to the output of this module. So I've already connected the output probes to the alligator clip. So I will connect the positive to positive, negative to negative of the multimeter. So I've connected the positive and negative to negative. Right, so now we will measure the voltage. So now it's in voltage point. Now I'll set it to 20, so 200. So now I've already been using this, so it's already set to 12 volts. So if I want to change the voltage, you have a knob here that is tunable, so you can tune it to clockwise or anti-clockwise, so you can vary the voltage. So if you want to control 10 volts appliances, you can set it to 10 volts as an output. So if you want 5 volts, you can set it as 5 volts. So now in my case I need 12 volts because mostly I have 12 volts components to be controlled. So I will set it to 12 volts, and it can go up to 25 volts. That is less than the input voltage. So I'll make it 12.3 or 12.5 so that I can use more devices. Okay, let's start setting up the cooling fan. So I will just remove, and also let's check the current. So I will turn it off and then set this to 10 amps, and here, okay, so we get a current of 2.4 amps in the output. So I will turn this off. So now as this current is more than 2 amps, we need to immediately provide a heat sink or a cooling fan. So I have a cooling fan already. So here is the cooling fan. So I will connect, I'll just turn this off first. Connect the positive to positive and negative to negative of the cooling fan. Then I will just provide a support, and I will place the cooling fan over the top. Right, so now we are ready. See that you properly insulate for avoiding short circuit. So now let's turn on, and we can see our fan, cooling fan started working. Right, now let's start checking the components one by one. So let's start with the bulb, that is the 12 volts bulb. So already we are getting a 12 volt output. So now it's easy for us to test one by one. So I have the bulb with me. It's an LED bulb. So let me connect the alligator clips to this point over here where I get the output. Okay, so now let me place the bulb here and then connect the terminals. Always start connecting the negative side and then the positive side. So I have the negative side that is given in black color. You also call it as ground. Now, yes, we should be able to see our light glows. Right. So what happens in case if you're adding more devices is that even if the number of devices increase at the output, this LM2596 module will maintain a stable voltage at the output, that is 12 volts. Next, we will test the fan. So I have a fan here. Let me place this to the side. I have a fan. So let me connect the terminals. Let me connect positive to positive. Sorry, negative to negative and positive to positive. and you can see that the fan started rotating, which is at a good speed. And the rating of this fan is DC 12 volts, 1.4 amps. So if you use a fan like this, it will use most of the current. I have a 50 watts inverter that is specially made for solar. So that says 50 watts, 220 watts. So if you want to connect low voltage appliances like small AC bulbs that we use in our home, you can use this. So the DC will be the input 12 volts, and the output you can get 220 volts. So let's test this one also. So I will connect the positive and negative terminals to the alligator clips that we have. So the negative goes to the negative and positive goes to the positive. Okay, now we have our AC output ready. So if we turn on, we get the output. So let me use this electrical appliances that is below 10 watts and turn it on. You can see it works. And also this comes with a USB cable connector so that I can connect it for charging small appliances. So we will test that also. Okay, now I've connected a USB cable that is of USB 3C type, and the other end, let me connect it to some charging appliance. So I have a small handy fan here, to which I will connect this and see whether I'm getting charge. And yeah, you can see the blink here, so that it means that we are getting solar power to charge through the USB cable. So this is how you can extend your connections to different 12 volt appliances. I hope you understood the connections. So now we have completed our solar powered home. So let me turn on the circuit. So here is the switch for the power supply from the solar panel. So I'm turning on the MCB. So as I turned on the MCB, we can see the cooler fan already started cooling the DC to DC converter module, that is the LM2596 that is placed inside. So let me turn on the appliances one by one. Here we have the switch for the fan and light. And then here we have the 50 watts DC to AC inverter. So I've connected 3 watts output light from it, and also this is charging the mobile here. As you can see, the charging status at the top. Before concluding this project, I will make use of this connections diagram to explain you in detail so that you will get a good understanding of what we have achieved today. So we took a 50 watt solar panel and we combined it with another solar panel of same specification, and we made it 100 watt solar panel. So in each 50-watt solar panel, you have a certain specification. So you need to go through this before understanding how much the watts, the power that the solar power generates. So here my solar panel generates 50 watts according to the specification and a maximum voltage of 20 volts and a maximum current of 2.51 amperes. Right. So after connecting both the 50-watt solar panel together in parallel, the solar panel output that we receive is a 100-watt solar panel. So the power doubles to 100 watts, whereas the voltage remains the same. That is, the voltage will be around 22 volts. So I take this output from here, from the solar panel, and I give it to 5 amps MCB. So this MCB is called as miniature circuit breaker, which trips the circuit in case of any short circuit happening between the positive and negative. Next, from this MCB, I give the output as an input to the LM2596 step down DC to DC converter. So before giving this input to the DC to DC converter, let's go through the specification here. According to the LM2596 specification, it says that the input voltage should be within 4 to 35 volts and the current should be between 2 amps and 3 amps, provided that if the current is more than 2 amps, you need to provide an additional heat sink or a cooling fan. Right, so I provided a cooling fan for cooling the DC to DC step down converter, that is LM2596. So to power that cooling fan, I make use of this output itself. So I use this potentiometer to get a 12 volts as a regulated output, and this 12 volts is used to power the fans and lights as also the cooling fan for the LM2596 module. Right, so this is how we get an output. So whereas the current over here practically that I got is 1.8 amps for one solar panel. So as a combination, after the losses, I was getting around 2.8 amps, which was within 3 amps. So I can use it to power this LM2596 module. Right, so coming to this DC components usage calculation, this table shows how to select and how many components can be used. So as the power says that 100 watts power is generated from the solar panel. So you can give a load up to 60 watts for efficient working. So I have just given some devices up to 60 watts so that you can refer this for using your solar panel more efficiently. So I am taking a 7 watts bulb and of quantity 2. So if I want to calculate the power of it, I need to multiply 7 and 2, that will be 14. So similarly, 11 watts bulb with a quantity of 2 will give me 22 watts, and a DC fan, which is run by a DC motor, has a rating of 1.8 amps and 12 volts. So to get the power, you need to just multiply this current and voltage, which will be 21.6. And finally, by adding all the three will be 57.6 watts, that will be between 60 watts. So with a good sunlight, you will be able to make these 60 watts devices efficiently. And now we have understood that we are able to use solar panel without battery. So the main things that you need to be careful is that you need to combine two solar panels of same specification. Otherwise, what will happen is that the solar panel will burn. For example, if you choose 50 watts, 150 watts, and another 60 watts, then definitely it will affect the solar panel.